Okay guys, today in algebra we're going to talk about what happens when you take a power times a power. What that means is if you look at number 1, I have y times y to the 5th. Well, if you notice, these two terms have the same base. I have y to the 1st power here times y to the 5th power. Now if I were to rewrite that and kind of write it out, y to the 1st power means I have 1y, and I'm multiplying that by y to the 5th power, which means I'm going to have 5 of those y's being multiplied together. Now, if I'm multiplying all of those things together, I have 1, 2, 3, 4, 5, 6 y's being multiplied together, so that's going to leave me with y to the 6th. Now, to simplify this process and make it easier to work with, all we really need to do is look at the exponents. Since my bases are the same, all I have to do is add my exponents. So y to the 1st times y to the 5th leaves me with y to the 6th. On number 2, I can try it again. So I have n squared times n to the 7th. So notice my bases are the same, and even though I have a negative exponent, I'm going to hold off on working with it until the end. So n squared times n to the negative 7th. I can add those exponents, and I'm going to be left with n to the negative 5th. Now, to simplify this, remember we can't have a negative exponent, so it needs to go down to the denominator. So that's going to simplify to n to the positive 5th and a 1 left in the numerator. On number 3, I have m to the 1st times m to the 6th. They have the same base, so I can add those exponents and get m to the 7th. On number 4, they throw a coefficient into the mix. We have a negative 7 here in front of my x's. Now, when we have that happen, we just handle the coefficients like normal. On my second term, my coefficient is a 1. So since these two terms are being multiplied, I'm going to take this negative 7 times 1 and get a negative 7. Then I can look at my variables. I have an x to the 2nd power times x to the 4th power, and since they have the same base, I can add those exponents and get x to the 6th power. On number 5, I'm going to multiply the coefficients, so 2 times 8 is 16. Then I'm going to multiply the variables. A squared times a to the 1st power is a to the 3rd power. On number 6, I have a coefficient of negative 1 and another coefficient of negative 1. So a negative 1 times a negative 1 gives me a positive 1. Then I can take my variables. I have an x to the 4th times an x to the negative 3rd. I can add those exponents, and 4 plus negative 3 gives me x to the positive 1st. So 1x to the positive 1st really just gives me an answer of x. On number 7, here I have 3 terms, but it's not a big deal. They're all the same base. So I have x to the 1st times x to the 2nd times x to the 4th. So I'm going to add all 3 of those exponents together, and I'm going to get x to the 7th. On number 8, here I have 2 variables being multiplied together. Not a big deal. We're just going to take it one variable at a time. If I start with my r variables, I have an r to the 1st here and an r to the 1st here. So I can add those exponents together, and I'm going to be left with an r to the 2nd power. Now I can look at my n's. I have an n to the 1st power, n to the negative 3rd power, and n to the 2nd power. So I'm going to add all of those variables together. 1 plus negative 3 is negative 2, plus 2 is going to leave me with 0. So that's going to leave me with n to the 0 power. Now, whenever you have an exponent that's a 0, something special happens. So if I were to pick any number that I wanted to, for example, what if I picked the number 7 and raised it to the power of 0, I'm going to get a result of 1 back. Or what if I chose 6 and raised that to the power of 0? I'm still going to get a 1 back. I could choose any number that I wanted to, and if I raise it to the power of 0, I'm always going to get a 1 in return. So, on number 8, when I have an n to the 0 power, that's actually only 1, which means that my result here, my answer, is just r squared. Now keep that in mind for when you have really complicated problems in the future. You might see really crazy variables with high exponents and weird numbers and all over whatever, and if it's raised to the 0 power, it doesn't matter what's on the inside of that. You don't even have to look at it. Whatever your answer is, it's going to be 1 because it's raised to that 0 exponent. Alright, on number 9, I have negative 4x to the 3rd times negative 5x to the 7th. So I'm just going to focus on just the coefficients first. I'm going to take that negative 4 times negative 5, and I'm going to get a positive 20. Then I'm going to take x to the 3rd times x to the 7th, and I'm going to get x to the 10th. On number 10, I have two variables again, but that's okay. Take it one variable at a time. I'm going to take this L squared times L to the 3rd, and I'm going to get L to the 5th. And then I'm going to take this K squared times K, and I get K to the 3rd. Now, I cannot combine these two guys because they are different bases. If they had the same base, then I could add those exponents, but since they don't, they have to stay separated. On number 11, I have 5a to the 7th times 4a to the negative 2nd. So 5 times 4 gives me 20. Then a to the 7th times a to the negative 2nd. Add those together and I get a to the 5th. On number 12, we'll take negative 5 times a positive 3 and get a negative 15. Then I'll take an m to the 3rd times m to the 8th, and 3 plus 8 gives me m to the 11th. Now here on number 12, remember, coefficients are allowed to be negative. I do not have to move this guy because the exponent is positive. Only when the exponent is negative is when you have to make some changes. So what I'd like you to do is pause the video and do number 13, 14, and 15 all on your own. Do these three right here all on your own. So hopefully on number 13 you got y to the 3rd, z to the 3rd. On 14 you got 4x to the 3rd, y to the 4th. And on 15 you got 6x to the 7th. Now on number 16, we're going to take these three terms and multiply them together. They all have the same base, so I can just add those exponents quick. 2 plus negative 3 is negative 1, plus 6 is 5, so I have a to the 5th. On number 17, I'm going to start with my coefficients. 4 times 3 gives me 12. Then I have x to the 1st and x to the negative 3rd, which is going to give me x to the negative 2nd. And then y to the 3rd and y to the 5th, which gives me y to the 8th. Now, if you'll notice, I have a variable with a negative exponent here. Now that can't happen, so we need to move just this variable to the denominator because this was like one big fraction. So, to do that, we're going to keep the 12 in the numerator and the y to the 8th in the numerator, but this x to the negative 2nd is going to come down here to the denominator and it'll turn positive. So 12y to the 8th over x squared. On number 18, I'm going to take this negative 2 times negative 4 and I'm going to get a positive 8. I'm going to take c to the 4th times c to the 1st and get c to the 5th. And then I have a d to the 1st and a d to the 1st, which gives me a d squared. Okay, next what I'd like you to do is pause the video again and do 19, 20, and 21 on your own. Pause the video and do the next three on your own. Okay, on number 19, you should have gotten negative 6, j to the 3rd, k to the 10th. On 20, negative 20, x to the 4th, y to the 6th, z to the 3rd. And then on 21, notice when you multiplied them together, you got a negative exponent, so you had to move that guy, and you should have gotten 7a to the 7th over b. Now on 22, I'm going to start again with my coefficients. Now be careful, I have three coefficients on 22. I have 1/3, 2, and 6. So I'm going to multiply those guys together. Now I know that 1/3 and 2 don't multiply together very nicely, so I'm going to take 1/3 times 6, and 6 divided by 3 gives me 2. And then I'm going to take that guy times 2, and so 6 divided by 3 is 2, times 2 is 4. Then I can look at my a variable. Well, there's only one a in my entire problem, so I'm just going to bring that guy straight on down. And then finally I have a b and a b to the 3rd, which gives me b to the 4th. On number 23, I'm going to take 5 times 1/5, and that's going to leave me with a coefficient of 1. A squared times a gives me a to the 3rd. B times b gives me b squared. And then c to the 3rd times c to the 4th gives me c to the 7th. On number 24, I'm going to start with multiplying my coefficients together. So negative 5 times 4 gives me negative 20. Multiplying my x's together gives me x to the third. And then my y's are going to give me y to the fifth. Next, we're going to talk about what happens when you have a number as the base instead of the variable. We're going to get some more practice with this. When you have a variable as your base, your final answer is just going to stay as a variable with an exponent. So for example, x squared, we can't do anything more than that. However, on number 25, I have my base is a number. My number is 5 here. When that happens, you need to simplify to get a final number, because we know that we can take 5 and square it, because 5 squared gives me a result of 25. Now on number 26, I have 4 to the negative third. Now, I don't like negative exponents, and you are not allowed to just put it into your calculator. We have to move some things around. This is currently in a numerator, and it is negative, so I need to move it to my denominator, and it's going to become 4 to the positive third. Then, whatever's left in the numerator is just a 1. Now to figure out what that is exactly, I can just use my calculator and determine that 4 to the third is a positive 64, so 1 over 4 to the third is 1 over 64. Now this isn't much work, but I do need to see it for you to get full credit. On 27, I need to take 2 to the fourth because I have a base of 2, and I'm raising it to the fourth power, so again, just put it in your calculator. 2 to the fourth power is going to give you a result of 16. On number 28, I have a negative exponent, so I need to move it to the denominator, and that's going to be equivalent to 1 over 14 squared. Now we should know what 14 squared is. If we raise 14 to the second power, we'll get 196, so that's going to give me a result of 1 over 196. Next, I'd like to pause the video and do 29 and 30 on your own. 7 to the fifth, you should get 16,807. And 9 to the negative 6 actually gives me 1 over 9 to the 6th, which is 1 over 531,441. Next, we're going to talk about how to find the area of certain shapes when you have these terms as your length. So for example, on number 31, it says find the area of each figure. Now this is a rectangle, and the first thing we need to do is start by writing down what the formula is for area of a rectangle. Well, area of a rectangle is the length times the width. Now I need to figure out which one's the length and which one's the width and substitute them in. It doesn't technically matter which is which, because you could rotate the rectangle and it would change anyways, but I'm going to use x to the fifth as my length and x squared as my width. Now I can multiply them together, and since they have the same base, I add the exponents, and my area of this figure is x to the 10th. We can try it again on number 2. Again, I know number 2 looks like 32 looks like a square, but it's still technically a rectangle. So I'm going to say area equals length times width, and then I know that my length and my width doesn't matter which is which, so I'm going to let my length equal c times d, and my width equals c times d. And when I multiply those together, I get c times c, which is c squared, and d times d, which is d squared. So the area of my figure here is c squared d squared. On number 33, I have a triangle. Just a friendly reminder, the formula for area of a triangle is 1/2 times base times height. And you need to write down the formula first for every single problem. Now I can substitute in what I know. I know that 1/2 stays the same. My base here is 9 times p cubed, and my height is 4p. Now to multiply them together, all I need to do is start with the coefficients. So 1/2 times 9 times 4, half of 4 is 2, times 9 is 18, and then p to the third times p gives me p to the fourth.